Assalamualaikum warahmatullahi wabarakatuh. We will present our mini group project for data warehouse subject. The title is Daily Mart Retail Sales Data Warehouse. The introduction is, in today's competitive retail landscape, organizations must leverage data-driven decision-making to understand customer behavior and optimize business efficiency. While Daily Mart generates vast transactional data across its supermarket chain, its operational database are not built for complex analytical tasks like trend analysis or long-term forecasting. To bridge this gap, this project develops a retail sales data warehouse, creating a centralized repository that integrates sales, customer, product, and store data. By utilizing a star schema model, the system supports a multi-dimensional OLAP operation such as roll up, drill down, and slicing to transform raw data into actionable insights. Through the design of robust fact and dimensions tables, the implementation SQL analytical queries, this framework empowers Daily Mart to enhance its business intelligence, improve strategic decision-making, and secure a significant competitive edge in the retail industry. For the group member contribution, is Helmi did introduction, member contribution, DML sample data insertion. For Nurhani Nabila, she did star schema design, diagram, fact table explanation. For Ms. Suhai Amani, organization background and conclusion writing. Last but not least, Muhammad Taufik did SQL, DDL implementation and dimension table design. Task schema. The purpose of schema is designed to organize the Daily Mart retail sales data in a simple, fast, and efficient for analytical queries and business intelligence operation. It places the fact sales table at the center, representing each sales transaction, and connects it to 5-dimension tables. Dimension product, dimension category, dimension customer, dimension store, and dimension date, forming a star-like layout. Next.
So, Assalamualaikum warahmatullahi wabarakatuh. My name is Nurhani Nabila, and I will present more about the star schema. So this is the visual of the star schema in our project. In the slide, we have a central box labeled sales surrounded by 5 connected boxes. Dimension product, dimension in category, dimension customer, dimension store, and dimension date. Next. So now let's talk about what this structure actually does for Daily Mart. Our objective fall into 5 key areas. First, multi-dimensional analytics. We can now track performance across all 15 branches from Kuala Lumpur to Johor Bahru and instantly see how specific categories like fresh produce or electronic are performing. Second, fast query performance. We handle about 20,005 transactions every day and serve over 50,000 monthly customers. By separating our numbers like quantity sold from descriptive details like customer names, the system remains lightning fast even during peak hours. Third, a single source of truth. We have consolidated data from every branch into one central repository. No more manual reporting, discrepancies or conflicting numbers between the Melaka and Penang office. Fourth, next slide. Okay, fourth, flexible all-up operations. This is where the power lies for our analysis. We can slice the data to see only Penang sales, dice it to find what gold members bought in Q4 or drill down from a broad category to a specific product's performance. Finally, simplified AI. This is not just for IT, it's for management. This schema fits directly into our dashboards, allowing us to track KPIs, identify underperforming inventory, and optimize our resources during busy festive seasons. Next. So this is the detail about the star schema of fact table. First, we have sales ID, product ID, customer ID, store ID, date ID, quantity, unit price, and total amount. Next. For dimension product, we have product ID, product name, category ID, brand, and unit cost. Dimension category have category ID and category name. For dimension customers, the table have customer ID, name, gender, and city. Beside, dimension store have store ID, store name, location, and manager. And lastly, dimension date have date ID, full date, day, month, quarter, and year.
I will for the 5 interesting case from using the 5 OLAP. Firstly, we will use the roll up operation, which is up with the business question of what is the total sales revenue for each product category across all stores and time periods. First of these queries is to help daily mart management identify which product categories fresh produce, groceries, personal care, electronic, and generate the most revenue, enabling the strategic decisions on reinvestment and space allocation. So the explanation for this OLAP operation is it aggregates detailed sales data from individual products up to the category level, rising sales across all stores. It's a high-level view of category performance. As we can see, SQL are as shown, and this will the output is here. So we can see that total units sold that have the most is the groceries categories, which have the number of section 7. Then it drill down. So for this OLAP operation, we have of what are the top 10 individuals by sales revenue the electronics. So the purpose of this question is to drill down from category level performance to identify specific high performance products, helping with targeted promotions and supply negotiations. This OLAP operation break down aggregated category data into granular product level details, specific items, category performance. Here is the SQL query. And when we run this SQL query, the output of it will be as shown below. So from this output, you can see that the highest average sales price is Bluetooth speaker, which the revenue have 508 and have 2 units sold. Next, then is slice operation. So this operation will have the question of what is the most monthly sales trend of the across all product stores and customers. Because of this query, help daily mart identify seasonal peak shopping and periods during products to boost sales. So this operation filters the data cube along one dimension, is time dimension, showing only while keeping the dimensions products stores and customers aggregated it down here part of the next is test operations. So this then we'll have the question of what is the sales performance of customers purchasing groceries products stores located in Kuala Lumpur during Q4 of 2024. The purpose is to enable Daily Mart to perform targeted customer segmentation analysis, helping design personalized marketing campaigns for specific customer demographics in the locations. This operation applies filters across multiple dimensions simultaneously, which are the customer, property, and time period, creating a subcube of highly specific data. For the operation is as shown here of the SQL query. Here, see from the output, the store in branch Kuala Lumpur have the total revenue and 58 with of 5 units sold with unique customers of 2 and with the total transaction of 2 transactions. And lastly, we have the private operations. This operation is by the business question show a comparison of quarters revenue across different store locations for 2024, quarters as column and stores as rows. Of this operation is daily management with metrics for performance, making it easy to identify seasonal patterns and underperformance. So this operation rotates the data presentation, transforming quarter values into columns, creating a cross-tabular view that facilitates easy comparison across time periods and regions. So the SQL query operation is as the output is as shown here, and we can see for the store Daily Mart in KL Central, which is located in Kuala Lumpur, for the total for the performance for Q1 until Q4 is shown here, and the total annual revenue for the year 2024 is 3,728.50. Is for the DDS statement. I will pass to Isilmi.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Isilmi Feshan Sulari. Next, I will present you about the DDL and DML statement. For the DDL statement, we have many tables, which the first one is for table dimension category. So we create dimension category table, which is we put category ID as a primary key, and next attribute category name, we set a varchar with not null. And second, we create a table with dimension product. So we create the table for dimension product. We have a product ID for the primary key and the attribute product name using varchar, category ID using int, brand using varchar, unit cost using decimal, and we foreign key it with category ID and category ID from the dimension category. Next, the third table is the dimension customer. So we create the table dimension customer, which is customer ID as a primary key. Name we set for varchar, gender we set for varchar, and city also we set for varchar. And the fourth one is dimension store table. So this table we create as we put store ID as a primary key, and the next attribute store name we use varchar, and location we put varchar, and also manager we also put varchar. And next table is dimension date. For the dimension table date, we put date ID as a primary key, full date we put as date, and category is not null, and day we put as a int, month also a int, and quarter we put varchar, and also year we put int. And the next table is the fact sales table. So the facts table has many foreign key and also attribute. So we put the sales ID as a primary key, product ID we put as a int and put it as a not null. Customer ID also we put int and set it as not null. Store ID also int and also put as a not null. The ID we put it as a int and not null. Quantity also int and not null. For the unit price, we set it as a decimal and category as it not null. Total amount decimal and we category it as not null. For this table, have four foreign key, which is for the FK product ID and product ID from the dimension product. And second foreign key, customer ID. We foreign key with the dimension customer using customer ID, and also the third foreign key, store ID, refer with the dimension store using the store ID. And also the last foreign key, which is the date ID, we refer from the dimension date using the ID. So next is the DML statement. For the DML statement, we use for this to insert data using query. So for the table dimension category, we insert, for example, one and fresh produce. So one is category for the category ID, and also the fresh produce is stand for the category name, and also the next value also. And the third table and the second table for the dimension product, we put insert the value, which is, for example, the product ID, we insert 101 as the product ID, fresh milk as the product name, one as the category ID, from fresh is the unit brand, and also 5 ringgit 50 cents, which is the unit cost for that product. And the third table is the dimension customer. So we insert the dimension value table here. 1001 is for the customer ID. Ahmad Abdullah for the name. Male is for the gender. And also the Kuala Lumpur is for the city of it. And the next table for the dimension store, we insert data, the value is for example, 201 is store for the store ID, and Daily Mart KLCC is there for store name. Kuala Lumpur is store for the location, and also Azmi Rahman is there store for the manager. Next, and the next table is the dimension date. So we insert the dimension date table, which is the value we put here as 2024-0101 store for the date ID, and also 2024, and the month is January and the date is 15. We store for the full date, and 15 for the day, 1 for the month, and Q1 for the quarter, and year is the 2024, and for the next value also. And the last table is the fact sales. So we insert the fact sales table using the value, which is, for example, 5001 for the sales ID, 101 for the product ID, 1001 is for the customer ID, and 201 for the store ID, and 20240101 for the day ID, and 2 for the quantity, 6 ringgit and 50 cent for the unit price, and also the 30 ringgit for the total amount for the pack sales. So these are the DML statement. So the conclusion I give to Amani. Thank you.
Okay, for the conclusion, in summary, this describes a retail sales data warehouse or daily mart using a star schema design that organizes sales data in a clear and efficient way. By integrating data from products, customer, store, and time dimension, the system enables better analysis and supports reliable business intelligence through structures SQL implementation. Additionally, OLAP operations such as roll up, drill down, slice, dice, and pivot allow Daily Mart to analyze sales trends, customer behavior, and branch performance more effectively. This helps reduce manual reporting, improve decision making, and supports the company's strategic goals for future growth. That's all from us. Thank you.
Thank you.
Thank you.
Thank you, Dr. Azlan.